Hello, it's Keith here, and this is lesson 4 in the so-called MinTile series of my Z80 assembly programming tutorials. Now, this is in which we're looking at the software tile map program, the one you can see on screen here. This allows sprites to move around the screen, simulated sprites, I should say. And we've got a tile map, and you can see we can scroll the tile map. Now, we're going to be looking at the last part of the code today. That is the so-called zeroing routine. Now, not all of the screen is redrawn every frame because this doesn't use a double buffer. That was part of the design of the software because some systems don't have enough memory for a double buffer. So it's only using a single buffer, and that means when an object moves and is redrawn, you're going to see some flicker. Now, in the case of my sprite moving across the screen here, almost in all cases, there's very few tiles that actually need to be redrawn because the old position of the sprite and the new position of the sprite will overlap each other. So what we want to do is we want to work out the old tiles that need to be redrawn, but then remove those tiles that are going to be replaced by the sprite that's about to be redrawn to the screen. And that's what this zeroing in the cache is. It's taking the items out of the cache that are actually going to be overlapped by a sprite when that's drawn in just a moment. And that's the code we're going to look at today. Now, I should point out that this code today is not perfect. MinTile is a crude tile map. It's a very simple tile map, and it does have some limitations. Now, if you look at the Chibico character that we've got on the screen here, you can see that while this is a sort of rectangular sprite object, around the feet are actually transparent, and sometimes you can see there's some glitching, and that's because this code isn't really optimized for sprites that have transparent areas. Unfortunately, that is a limitation of this version. I'm working on an upgraded version called MaxTile, which has a lot of extended functionality. It supports Y flip as well as X flip, and it supports a lot of other things. But for this simple version, that is a limitation. So that's just the way that this code is. So we're going to look at the code, and we're going to see how this so-called zeroing routine is going to be performed. Okay, let's take a look. Okay, so here is our code then, and it's this zero sprite in cache. This is that we're going to look at today. So this is executed in between removing the old sprite and drawing the new sprite to clear the cache of the objects that don't need to be redrawn. So the first thing we're going to do is we're checking the refresh tile flag of the current sprite object. Now, if that is set to 0, then we don't need to do anything because we've not been told to redraw the sprite at all, so we certainly don't need to zero it. So in that case, we just return. We're then clearing the flag because we're doing the refresh now. We're then loading in the X and Y position of the sprite. Now, what we're going to do after that, we've got some options. Now, as I say, there is a problem with regards to basically partial tile movements, so half tile movements. The sprite can move half a tile, but the drawing routines get a little bit glitchy. So if we want to make everything's nice and clean, but we don't need to move in smooth movements, and 8x8 jumps, pixel jumps is satisfactory, we can use these low-res X and low-res Y options. And on the Sega Master System, where we're using tiles to draw the Chibico character anyway, that doesn't have any disadvantages, so you would want to do that. Now, after that, we're loading in the width and height, and we're moving those into H and L here. And then what we're doing next is we are basically going to have to calculate the area of the sprite. Now, if you imagine that this is our sprite, now our sprite has a large box area, but we aren't going to want to zero all of that area. We just want to basically clear the area one tile less than all of the edges. So we're clearing an area allowing for the outside edges to be redrawn, and that is again part of this problem of we are allowing partial tile movements, and we're redrawing to compensate for that, and it's only when the transparency of that area comes in that the glitches will start. We are able to cope with partial movements of a completely filled sprite, but where there's transparent areas within that sprite, like the smaller feet than the width of the torso of the character for today's example, that does become a problem. As I say, those feet are less wide than things like the wings in that example there. So that is the problem. Now, what we're doing here is we're basically checking the current position of the X position and then later on the Y position, and we're checking if we are set halfway across a tile. Now, if we are, then we're basically increasing the X position by 1/2 unit and decreasing the Y position by 1/2 unit. Units, I mean tiles here. And then we're basically rounding the X position up to the nearest tile and the Y position down to the nearest tile. So this is effectively reducing the area and increasing the X position, and that's the area we're going to zero, so that we're not removing areas that that might have tiles that need redrawing because of that half movement. Okay, so that's what we're doing there. We're then doing the same for the Y position. And what we're going to do next is we are going to perform the do crop routine. Now the do crop routine handles the fact that our character might be partially off the screen, because if the character is partially off the screen, the drawing is going to be partially off the screen, and that means the zeroing of the cache needs to represent that. And so we're recalculating the area using the do crop routine here. And then we are going to basically convert the logical coordinates, which are in pairs of pixels, to a number of tiles. And that routine there is basically just dividing the x pos, the y pos, the width and height by 4. We do have a correction though if our sprite is x flipped. Now again, this is something that the MinTile engine does support, because I wanted it for the Chibi Fighter game I was going to write with it. However, the support is a bit limited, to say the least, and so there are some mathematical corrections that have to be made, and that is one of them. Again, the Max Tile engine that I'm planning to write does not work in the same way for X flipping. It will not have those graphical glitches and mathematical calculation corrections, shall we say. So there we go. So that's calculating our X pos, our Y pos, our width and our height. Now what we're going to do next is we're going to basically calculate the tile maps. So we've got a miniature tile map for our characters tiles, which we can see just here. This is the Chibico graphic as a tile map. You can see those zeros there are the empty parts around the feet, and that zero in the corner there is the top corner, which is also has no tile drawn in it. And so we're going to calculate the position in that we need to draw, and then we're going to calculate the matching position within the background tile map. So we're going to load the source tile map in DE here, and then what we're going to do is we're going to basically take the tile cache. This is the background tile map, which is 32 by 24 tiles, and we're going to offset our memory location within that for the XY position of our sprite, because if our sprite is here and our tile cache starts up here, we need to move our memory address so that we're only clearing the area that the sprite is actually overlapping. And so that's what we're going to do here. So that shift tile map routine here will update the tile cache address, and it will calculate the new destination for the area we actually want to fill. Now the width of the tile map, the tile cache, is 32 tiles, which is 20 in hexadecimal. And then what we're basically going to do is we're next going to check if the tile map needs to be flipped. If it does, then what we're going to do is basically we're going to work in the opposite direction. So we're flipping our starting position here, and we are using some self-modifying code here to modify the zeroing routine, so that instead of using an inc.hl, it's using a dec.hl. 2b is the hexadecimal value for a dec.hl command, 2.3 is the hexadecimal value for an inc.hl command, and we're modifying that back in after we've run the zero tile routine. None of this will happen if we are not flipping the sprite. We would just run the routine in at the normal mode there. Now what we do need to do though is if we're running from RAM, we will use self-modifying code to patch that value straight into the code. If we are running from ROM though, we can't use self-modifying code, so we're just patching it into a variable. That will be a little bit slower though. And then the zero tile routine here is doing the actual work. So what it's going to do is it's going to read in a tile from the source tile map. So that is the character, so like this one here. And it's going to check basically if that tile is 0. If it is 0, then we don't want to do anything, because this is an empty entry anyway. If it's not, then we want to zero that entry within the tile cache. So what we're doing here is we're writing a 0 to the DE tile cache, which is the updates that need to be drawn to the screen. We are then incrementing the tile cache, moving to the next entry within the tile cache, and then we will either inc or dec.hl depending on whether our sprite is X flipped or not. So that will depend. Here is the ROM version, which is just a compare. Here is the RAM version, which is self-modifying code. That inc.hl will be converted to a dec.hl by the right of the 2b value to the memory address just here with that calculation. So that is going to be self-modified in that case. We're going to repeat until we've done an entire line. We're then going to move the tile cache down by one full line. That is hexadecimal 20, 32 bytes there. And then we're going to increment our source sprite data by whatever the width of the source sprite data is, and we're going to repeat. So the source sprite is once again this data here, which is going to be the drawing for our tile bitmap graphic, so our simulated sprite, so to speak. So that is how we are basically doing this. And so this is our sprite, and you can see that this corner here is got no sprite data there. As it moves, you can see it's what I would call transparent, and that is that 0 there. So that's how we're doing it. And as I say, basically the zeroing is being done to minimize the flicker because we don't have a double buffer. Now, why don't we have a double buffer? Well, the answer is simple. This is a minimal timeout routine. Some systems have very little memory, and so I wanted to create a basic minimalist functionality timeout that could be used for multi-platform games that could work on a lot of systems in the same way and provide a comparable level of functionality. It was designed for my Chibi Fighter game, which was written for a variety of Z80 systems. I'm not porting it to any more because of the time constraints, but the MinTile engine is the same across all of the systems. So hopefully it could be useful to you. Now, if you're interested, go to the website, download the source code, the build scripts, as I was saying. I'm not saying that you should use this tile map engine. I'm not saying it's good enough. What I'm saying is take a look at it, see how it works, and see if there's some code in there you want to use in your own projects. And as I say, you're welcome to use anything from this tutorial or any of the others in any of your own projects, even if they are commercial. If you somehow manage to do that, you're welcome to do so without giving me credit, even, because I don't care. I just want you to get some benefit from it. So take a look. Anyway, I hope you've enjoyed what you've seen today. Thanks for watching, and goodbye.